4 decades of the most comprehensive aviation sanctions ever imposed on a country. No Western aircraft, no Western engines, no Western spare parts. And yet, Iran just built their own military turboprop. Meet the HESA SIMORGH. And the story of how it got here is stranger than the aircraft itself. To understand why the SIMORGH exists at all, you need to go back to 1995. And you need to understand what Iran was trying to do and why it went so badly wrong the first time. Iran's aviation industry had been more or less cut off from the Western world since the revolution in 1979. Boeing, Airbus, Pratt & Whitney, General Electric, all of them off limits. The country was flying an aging fleet of Boeing McDonnell Douglas airliners kept alive on smuggled parts and considerable ingenuity. But the military transport side of things was in a similarly difficult position. The Islamic Republic of Iran Air Force had a collection of American and European aircraft it had, inherited from the Shah's era, and could no longer replace or easily support. The Fokker F-27s in particular were getting old. Something new was needed, and Iran could not simply go shopping for it. The question was where in the world a state under those kinds of restrictions could find a willing partner who had something worth building. So in 1995, Iran turned east. The collapse of the Soviet Union had left Ukraine with a state aircraft manufacturer, Antonov, that desperately needed export customers and was not in a position to be too selective about who those customers were. Iran had money, at least at that point. The two countries signed a deal that gave Iran a production license for the Antonov An-140, a modern 52-seat twin turboprop that Antonov had designed as a successor to the venerable An-24. The logic was sound. The An-140 could operate from short and unprepared runways. It was tough, practical, and designed for exactly the kind of regional transport work that Iran needed. HESA, the Iran Aircraft Manufacturing Industrial Company, based in Shahin Shahar in Isfahan province, would assemble the aircraft from knock-down kits supplied by Ukraine. Iranians and Ukrainians would work side by side. What happened next was one of the most troubled aircraft programs in modern aviation history, and understanding that failure explains exactly why the SIMORGH had to exist. Keep that in mind as we go through what came next, because without the Iran An-140 in all its dysfunction, there would be no SIMORGH. The failure built the engineers who eventually built the solution. On the 23rd of December 2002, a Ukrainian An-140 operated by Aeromist Kharkiv took off from Kharkiv carrying 44 passengers. Most of them were senior engineers, executives, and aviation specialists from Ukraine and Russia, on their way to Isfahan to attend the rollout ceremony for the first completed Iran An-140, the Iranian license-built version. Among those on board were Antonov's Deputy Director General, who had personally supervised the entire Iranian program, the Deputy Chief Designer, and 5 departmental directors from the Kharkiv factory. The aircraft never arrived. On approach to Isfahan, the crew used a GPS navigation system that had not been approved for instrument approaches. It gave them incorrect guidance. The aircraft flew into a mountainside 70 kilometers from the airport. All 44 people on board were killed. The death of so many people who had been central to the program was devastating. But Iran pressed on. The Iran An-140 continued to be assembled at Shahin Shahar through the 2000s. By 2010, 14 aircraft had been completed. Problem was that by then, US political pressure on Ukraine had persuaded Antonov to stop supplying spare parts. The supply chain that the entire program depended on was cut off by sanctions and diplomatic pressure, leaving HESA with aircraft it couldn't properly maintain. Then came the crashes. In February 2009, an Iran An-140 crashed during a training flight at Shahin Shahar, killing all 5 crew members on board. Engine failure on takeoff. In August 2014, a Sepahan Airlines Iran An-140. Sepahan Airlines was essentially a captive airline owned by HESA itself, which tells you something about the commercial appetite for the type, crashed shortly after. Takeoff from Tehran, 40 people died. After that, Iran's Civil Aviation Authority grounded the entire Iran 140 fleet. Production, which had limped on to around 15 aircraft total, effectively ended. The dream of building a regional airliner in Iran had crashed in the most literal sense, more than once. One more detail from the crash history is worth understanding because it reveals something specific about the institutional context around the Iran 140 program. When the aircraft that crashed in Tehran in August 2014 killed 40 passengers, the airline operating it was Sepahan Airlines. Sepahan Airlines was not an independent commercial carrier. It was owned by HESA, the same company that had built the aircraft was operating it through a subsidiary it controlled. When external commercial operators had difficult experiences with the Iran 140, Safiran Airlines returned its aircraft to HESA after an engine failure forced a runway overrun in 2005. HESA essentially absorbed them back into the program. By the end, the only airline willing to fly the type regularly was the one that had no choice but to fly it. That is not a criticism specific to HESA or to Iran. It is a pattern that appears in troubled aircraft programs across aviation history. When the independent market stops buying, the manufacturer becomes the operator, and that creates incentives that do not always serve safety. The investigation into the 2014 crash was conducted by Iranian authorities and concluded with a certification declaration from the defense minister. International aviation experts were skeptical. The aircraft was subsequently grounded by the Civil Aviation Authority anyway. All of this is the context inside which the decision to develop the Simorgh was made. Not a clean break from failure, but a deliberate re-engineering effort by people who had lived through every stage of what went wrong and believed, with some justification, that they understood the problem well enough to solve it. Here is where the story pivots. Because HESA's engineers didn't walk away from the airframe, they walked toward it. Rather than abandoning the An-140 platform entirely, the team in Isfahan began what they described as a research and re-engineering program. The goal was to take what they had learned from 15 years of building and operating the Iran 140, including everything that had gone wrong, and produce something new, something that addressed the operational shortcomings, something that fit Iran's actual military needs rather than the original civilian brief, and something that could be built and maintained without depending on Ukrainian or Russian component kits that could be cut off by the next round of sanctions. The key insight was that the airframe itself was not fundamentally flawed. The An-140 was a sound design. What had gone wrong in the Iranian program was of a combination of supply chain dependency, engine reliability issues with specific batches of TV3-117 units, and the basic operational mismatch between a 50-base, two-seat passenger turboprop and what Iran's military actually needed, which was a cargo hauler with a ramp. So the engineers kept what worked, they redesigned what didn't, and they made the aircraft military from the outset rather than trying to adapt a civilian airframe for military use after the fact. By 2016, this effort had formally become the Simorgh project. Simorgh is the name of a mythical bird in Persian literature, a benevolent, all-knowing creature that symbolizes wisdom and strength. It is not a coincidence that an aircraft built to rise from the ashes of a failed program was given that name. The prototype was publicly unveiled on the 19th of May 2022 in a ceremony at the HESA factory in Isfahan, attended by Iran's defense minister Brigadier General Mohammad Reza Ashtiani, the head of the Civil Aviation Organization, and senior military officials. Looking at photographs of the Simorgh next to the Iran 140, the differences are immediately visible. The most obvious one is the rear cargo ramp. The Iran 140 was a passenger aircraft. Its fuselage ended in a conventional tail with no loading capability. The Simorgh has a raised rear section, similar in approach to the CASA CN-235 or the Antonov An-140, with a full ramp door that allows wheeled vehicles, standard pallets, and cargo to be loaded directly from the ground. This one change transforms the aircraft from a passenger carrier into a genuine tactical transport. But the ramp is not the only difference, and this is the part that most coverage of the aircraft glosses over. There is something worth noting about how the unveiling was framed, because the gap between what was said and what was left unsaid is itself informative. Defense Minister Ashtiani described the Simorgh as the product of Iran's domestic knowledge-based companies and praised the engineers of HESA for achieving self-sufficiency. He did not address the origin of the TV-3117 engines or the degree to which components in the aircraft trace back to designs that originated outside Iran. This is standard practice for military unveilings everywhere, and it is not unique to Iran, but it is a useful reminder that indigenously developed in the context of a country that spent 2 decades assembling Ukrainian knockdown kits means something more specific than it sounds. What is genuinely domestic is the design decision-making, the changes that distinguish the Simorgh from its predecessor, the wing planform, the stabilizer configuration, the ramp integration, the cargo system architecture, were made by Iranian engineers, solving Iranian military requirements without Ukrainian or Russian design input. Airframe heritage is real. So is the engineering independence from that heritage. Both things are simultaneously true, and understanding both gives you a more accurate picture of what HESA has actually achieved than either the Iranian official narrative or the dismissive Western coverage tends to provide. The wings on the Simorgh are rectangular. The Iran An-140 had trapezoid-shaped wings that tapered toward the tips. Rectangular wings generate more lift across their full span and are better suited to short field and rough strip operations, which is exactly the kind of environment the Iranian military needs to operate from. The horizontal stabilizers have also been changed. On the Iran An-140, they were configured in a slight V-dihedral shape. On the Simorgh, they are fully horizontal, which is a cleaner aerodynamic arrangement. The rear fuselage has been substantially redesigned to accommodate the cargo ramp and the revised tail. The engine installation has been reworked, and the cargo system is built around compatibility with 463 Lima pallets, the NATO-standard pallet used by military transport aircraft worldwide, which means the Simorgh can integrate with the same ground handling equipment used by any Air Force operating Western transport aircraft. That is a quietly significant detail for an aircraft being built outside the Western supply chain. The overall fuselage length is 23 meters, wingspan 25 meters, height 8 meters. These figures are broadly similar to the Iran An-140, which makes sense, given that the structural bones of the aircraft derive from the same lineage. The Simorgh is not a completely new design. It is a substantially modified and militarized evolution of an existing platform, which is exactly what HESA described it as. The distinction matters because a clean sheet design from a manufacturer with Iran's current level of isolation from international aerospace certification bodies would face obstacles that a military evolution of an existing type avoids, at least partially. The engines are 2 TV-3117 turboprops, producing around 2,500 shaft horsepower each. These are the same family of engines used in an enormous number of former Soviet designs, from the Mi-8 and Mi-24 helicopters to earlier transport aircraft. Iran has been maintaining and working with TV-3117 family engines for decades across its helicopter fleet, which makes the choice of power plant a logical one. The supply chain for these engines exists inside Iran in a way that no Western or Ukrainian alternative could. What Iran's engineers have done with them is less certain. Official Iranian sources describe the engines as a probably reverse-engineered and modified version of the TV-3117, though the exact specification has not been independently confirmed. The propellers are 6-bladed units, 3.6 meters in diameter, with constant speed, fully feathering, and reversible capability. The reversible pitch is particularly useful for short-field landing performance, since it allows the engines to act as aerodynamic brakes immediately on touchdown. At those power levels, the performance figures that Iranian officials claim become more plausible. Maximum speed is given as 287 knots. Range is 2,100 nautical miles at economy cruise with a reduced load, dropping to approximately 490 nautical miles when carrying the maximum 6-ton payload. Takeoff requires 1,450 meters of runway. Landing requires 900 meters. Both of those figures put the Simorgh within reach of a significant number of Iranian military airstrips and forward operating locations. The development timeline between the unveiling in 2022. Actual flight status is worth understanding because it reflects something real about where the program actually was when it was announced. The unveiling in May 2022 came when the aircraft was, according to Iranian military officials at the time, in the fast taxi testing phase. It had not yet left the ground. In April 2023, photographs appeared showing the prototype conducting runway taxi tests. Then, on the 30th of May 2023, Iran's defense minister posted video footage of the first actual flight test. The aircraft flew for 20 minutes at an altitude of 8,000 feet. Brigadier General Ashtani described it as completing according to international aviation standards. That first flight was more than a year after the public unveiling. For context, the gap between unveiling and first flight in a program like this is not unusual, particularly for an aircraft being developed without access to Western testing infrastructure or certification authorities. The Simorgh is going through Iran's Civil Aviation Organization certification process, which requires 100 flight hours under varied conditions before the aircraft can join the national fleet. Certification test flights began formally on the 28th of October 2025 in a ceremony attended by senior defense and transport officials at Shahin Shah. A second prototype is reportedly under assembly. Iranian officials have also mentioned the possibility of a passenger variant following the military transport, which would give HESA a dual-use production line if the certification process succeeds. The Civil Aviation Organization head noted that any aircraft holding an Iranian-type certificate would be authorized for international flights, which is an ambitious statement for an aircraft whose production is still in its early stages. Whether other countries will be willing to accept Iranian-certified aircraft on their domestic routes is a separate question from whether the certification itself is achieved. The operational role the Simorgh is designed to fill is specific, and it is worth being clear about what that is. Iran's Islamic Republic of Iran Air Force currently relies on aging Lockheed C-130 Hercules, the E and H variants, for tactical airlift, supplemented by Ilyushin Il-76 aircraft for heavier work. The Fokker F-27s that have served the utility transport role for decades are approaching the end of usable service life. A domestically built, ramp-equipped 6-ton transport gives the Iranian military a right-sized platform for missions that do not justify consuming C-130 flight hours. Routine troop shuttles, island resupply in the Persian Gulf, medical evacuation, spare parts movement, intelligence and logistics support to forward positions. In class terms, the Simorgh sits alongside the CN-235, which carries around 5,950 kilograms at a maximum cruise of 245 knots, and the Antonov An-140, which carries approximately 5,500 kilograms at a maximum cruise of around 237 knots. The Simorgh's claimed performance figures would put it at or above both of those in speed and payload. Whether those figures are fully achieved in operational conditions is a separate question, and one that only sustained fleet operation will answer. The elevated landing gear arrangement that some analysts noted in early photographs of the prototype, an unusual design choice that suggests the main undercarriage was positioned higher than on a conventional turboprop, also raised questions about ease of cargo loading without ground equipment. How HESA has addressed that in the production configuration will become clearer as the certification process proceeds and more photographs of the aircraft in operational conditions become available. There is a broader story here that goes beyond the specifications of one aircraft, and it is worth finishing on it, because it explains something about what the SIMORGH actually represents beyond a set of performance numbers. Iran has operated under some of the most comprehensive aviation sanctions ever imposed on a sovereign state. Since 1979, successive layers of American and European restrictions have cut off the country from new aircraft, engines, avionics, and spare parts. The result is an aviation industry that has survived on improvisation, smuggled components, and decades of accumulated technical knowledge, while its civilian airlines flew aircraft held together in ways that would not pass a Western airworthiness audit. The SIMORGH is the most visible product of a decision taken inside HESA to stop waiting for sanctions relief and start building the capability domestically. The head of Iran's Civil Aviation Authority described the SIMORGH's development as representing over 15 years of continuous effort and the commitment of thousands of Iranian engineers. That is probably an accurate description of how the program was experienced by the people involved in it. Whether the result is an aircraft that matches its specification sheet, meets the durability requirements of military operations, and can be produced in the numbers required to actually replace the Fokker F-27s and supplement the C-130s, that remains to be seen. The name SIMORGH was chosen deliberately. In Persian mythology, the SIMORGH is a bird that rises, that endures, that carries wisdom rather than destruction. It is a bird that, in the old stories, can be killed but cannot be permanently destroyed. HESA's engineers named their aircraft after it for a reason. Whether the aircraft lives up to that name depends on what happens during those 100 certification flight hours and everything that comes after them. The one certainty is that Iran is not stopping. A second prototype under assembly, a passenger variant under discussion, a new dedicated aircraft plant being established. 15 years of engineering work that did not disappear when the program ran into difficulties, but instead was redirected and refined until something flyable emerged. The SIMORGH exists because Iran decided a long time ago that waiting for the sanctions to lift was not a viable strategy. Building around them was the only one that made sense.